Hi everyone, this is chapter 4, day 2. Let's talk about what a relation and a function is. So a relation is a set of ordered pairs, where a function is a special type of relation, because in a function you can only have one and only element of the range matching up to each domain. So basically you can't have any repeating x's, because if you have repeating x's you have a vertical line, and as we already know, vertical lines are undefined, not functions. So these are different ways that you can show relations and functions. You can show them with ordered pairs, which we've done. You can show them using a graph. You can show them with a t-chart or a table. And you can show them with a mapping diagram. A mapping diagram is probably the only one that you haven't seen yet. And basically a mapping diagram orders them from least to greatest, your x's and your y's, and then it matches up your ordered pairs. So for example, here I know negative 13 goes with negative 7, so this was an ordered pair before I put it in a mapping diagram. Negative 5 goes with negative 2, so this is also an ordered pair. 5 goes with 22, another ordered pair. 23 with 4. And 31 with negative 10. So this one is a function because it doesn't have any repeating x's. See, there are no two arrows coming out of the x's, which means there would have had two ordered pairs with the same x. One way to determine whether or not something is a function when you look at a graph is by using the vertical line test. And basically the vertical line test says, as long as you only have one point touching each vertical line, then it's a function. Why? Because if you have 2 points touching the vertical line, at the same time, that means that you have two x's on the same vertical line, which makes it undefined and not a function. So if you notice here, the purple line is only touching my black vertical line one time throughout the whole graph. Whereas here, it touches the black line 2 times, here and here. Every time that I put my vertical line through the graph, it's touching in 2 different spots, which makes this not a function. There are different names for your x's and your y's. So we know domain and range. We know independent variable and dependent variable because we talked about the other day. We know input, output. These are all different ways to say the same thing, x and y. Function notation is basically writing an equation to show that it is a function. So these two equations mean the same thing, the y equals 2x minus 1, the f of x equals 2x minus 1, but this one is showing you that it is a function. So this is function notation, and the way that you say it is f of x. The parentheses would be of, x is what's inside the parentheses. F of x replaces to y to let us know that it's a function. So we treat it the same way that we would treat an x and a y. So if you look on this one, it says find the range of the function for the given domain. Well, I'm looking for the range, which means I'm looking for the y, and I'm given the domain, which means they gave me x. So to find this, all I have to do is plug into x. So f of x equals negative 3, and I'm going to plug in negative 1, because they gave me the domain. They want me to find the range given this domain here. So I plug in negative 1, I get 3 plus 2, which is 5. So there's one number in my range. If I plug in 0, I get 0 plus 2, which is 2. And if I plug in 2, I get negative 3 times 2 plus 2, which is negative 6 plus 2. So negative 4. So my range for this function is 5, 2, and negative 4. So what if you have to replace a function with another function? So instead of just plugging in a number for the domain, sometimes you have to replace functions with other functions. So here are my two functions, f of x equals 2x, and g of x equals x squared plus 1. So notice how I said g of x, this one has a g, this one has an x, to denote that they are two different functions. So look at this example, it says g of f of 4. So we're going to start from the middle, and we're going to plug that in first. So f of 4. That means I'm going to plug 4 into my f of x function, which gives me 8. So now I have g of, instead of f of 4, I know f of 4 is 8. And I'm going to plug that into my g function. So g of x equals 65. So g of f of 4 is 65. Okay, look at this one. It says f of 7 plus g of 9. Well, we do them separately. First, we plug in the 7 to the f of x. So 2 times 7 plus the function for g of x, which is x squared plus 1, except for now I'm plugging in 9. So 9 squared plus 1. And then I solve each one. 14 plus 9 squared, which is 81, plus 1. 14 plus 82, which gives me 96. So f of 7 plus g of 9 is 96. Try these two over here. Pause the video, take a second, and try those problems. Okay, go ahead and check your answers. We got 15 for the first one and -4 for the second one. Alright, so now let's plug in and solve these problems. All we did was make a t-chart, a little bit changed because now you're going to write in the equation first. And you want to pick good numbers when you're doing these problems, smart numbers. So for example, here I have a fraction. So I'm not going to pick -101, which I could pick here on this problem because there's no problem if I pick -101. But over here, if I pick -101, I'm going to end up with a fraction still, and I don't want to have a fraction. So I want to pick numbers that are going to eliminate my fraction or clear my fraction. And numbers that would clear my fraction would be numbers that the denominator goes into evenly. So 2, 4, 6, 8, 10, 12, anything like that. So I'm going to pick -2, 0, 2. And then I'm going to rewrite the equation. Y equals 1/2 times -2. Which gives me -1 for y, and my ordered pair is -2, -1. Plug in 0, 1/2 times 0, which gives me 0 for y, so my ordered pair is 0, 0. Plug in 2, so 1/2 times 2, which gives me 1 for y, and my ordered pair is 2, 1. And then I can graph that. -2, -1. 0, 0, 2, 1. Connect my points. Sorry, that's not very straight. And it makes my line. So you see I picked smart numbers and that gave me no fractions. Here, it doesn't really matter because I have no fractions to begin with. I could have picked any number. I picked -1, so 2 minus. Since there's already a minus, I'm going to put this in a parenthesis so I don't forget that it's going to become 2 plus 1. So 3, 0 minus, 2 minus 0, and 2 minus 1. So I end up with 2 and 1. And my ordered pairs are -1, 3, 0, 2, and 1, 1. And then I graph. And there is my line. Okay, on the next slide, you're going to try a couple. So go ahead and do those. This is absolute value. Don't forget, anything that comes out of an absolute value is positive. And here, keep in mind that the negative is separate from the x squared. Since it's not in a parentheses, you're going to do the exponent first and then attach the negative. So take a second and go ahead and do those, and then we will work on them together. So here are the answers. You notice with the x squared, it's a quadratic. It ends up making a parabola, which is a U shape. This one's an upside down U. And the next one, which was an absolute values make a V shape. So that's why this one looks like a V. So these are nonlinear equations or nonlinear functions that you just graphed. Check, make sure that you did it correctly. So a sequence is an ordered list of numbers that form a pattern, and a term in a sequence is one of the numbers in that list of numbers. So if you look at this first one, A, it shows you a sequence, 5, 8, 11, 14, and one of the terms would be 5, another term would be 8, another term would be 11. Each individual number is called a term. The pattern here is plus 3, plus 3, plus 3. So if you had to find the next two terms, you would just add 3 to 14, which gives you 17, and then add 3 to 17, which gives you 20. Look on the next one. The next one, again, terms, 2.5, 5, 10, 20. Your pattern is times 2. So these are two different kinds of sequences because one of them has an addition pattern and the other one has a multiplication pattern. When it's an arithmetic sequence, then the difference between the numbers is a constant difference, also called a common difference, which is an addition or subtraction pattern. When it's a geometric sequence, the difference between numbers is a multiplication pattern. So this one, which is what we're going to be talking about, is called an arithmetic sequence. So arithmetic sequences, again, they have to have a common difference. So it's going to be either added or subtracted the same thing every time. This one is not an arithmetic sequence because the numbers are different. They're being added different numbers. Here is a function rule for an arithmetic sequence. It's always going to look like this. A of n equals your first term, a of 1, plus, parentheses, the term number that you're looking for, minus 1, times d, which is your common difference or your pattern. So the way that you plug this in is you'll be given a set of numbers. So here's your sequence, for example. You have to find the common difference. 7 to 11 is plus 4, 11 to 15 is plus 4, 15 to 19 is plus 4. So there's my common difference. That's my D. And then you're going to be told what number to look for. So here it says you can find the 10th term. So you're looking for the 10th term, which means here under term number, you would plug in 10. Here under D, you would plug in the pattern, which is a positive 4. And then here in A of 1, you put the first number in the sequence, which is 7. And if I plug those numbers in, it gives me the 10th term in my sequence. So if I were to keep going till the 10th number, that number would be 43. Take a second and look at this problem down here and see if you can figure out an arithmetic sequence or a rule for this arithmetic sequence for the problem. See if you can find the function rule. Okay, so the first term is 100. The common difference, so if you go from 100 to 98.25 to 96.50 to 94.75, you see that you're subtracting 1.75 each time. So there's your common difference. So let's make our function rule. A of n equals first term 100 plus parentheses n minus 1 times your common difference negative 1.75. And then it says, what's the value of the pass after 15 rides? So at this point, you would plug in the 15 for n. And then you solve, and you'll get your number that you're looking for. Okay, that is the end of chapter 4, and good luck on your assessment.